Esher, would you mind turning off the light? At least one of them, if not both. Maybe both. Live on the wild side and put both off. Both, brilliant. We still have the daylight from outside. Okay, so in math, language matters. I think we've decided that with the titles of like domain and range, like they all have very purposeful things in math. So again, graphing and sketching, two similar things, but they are very different of what I'm expecting. So if I'm asking you to graph something, it needs to be accurate. You need to do it on graph paper. You need to have scale and increments. That means that those ticks along your X and Y axis, or your independent and dependent axes, need to be labeled. And you have to have a minimum of 2 coordinate pairs clearly labeled. FYI, this is more of a pre-cal thing. That's what we do a lot in pre-cal. Sketching is a little bit rougher. It's approximate. Oftentimes you can take the picture off a calculator. Your max min stated on the axis. So what that means is that I'm just going to say, okay, that's 10, that's negative 10, that's positive 10, that's a negative 10. So that's what I mean with that one. With the scale and increments, I'm looking for, okay, I'm going to go up by 2, 4, 6. Maybe these ones I'm going to go up by 1, 2, 3. So my increments are labeled. So you see how increments are labeled, and this is just your maxes and mins on your axis are labeled. And then key features are labeled. So key features would be like intercepts, which you have no idea what those are yet. Some key points that we're going to do on the graph. So that's kind of the more applied version. You often will graph it on your calculator, and you'll draw the picture from your calculator. In pre-cal, we do a lot more paper and pencil math, and we're looking for a more accurate description. In my grade 12 class, we're going to be graphing wave graphs. We started it last week, and we're going to continue it today. So, yeah, it's a good time. It's a good time. So to graph using a table of values, a linear relation, create a table of values, plot the data points on the coordinate plane. Select your x-axis. We know that our x-axis is horizontal. Do you guys know what horizontal is? That's like a left-right, like it's the horizon, so it goes this way, right? And then substitute each value into the equation that's been given and solve for the corresponding y values of the range. That one goes on your vertical. And vertical is up, down. So horizontal is left, right. Vertical is up, down. When an equation is written, x represents the independent variable and the y represents the dependent variable. And we're going to go ahead and graph the relations. We don't know if they're functions yet, so we're just going to call them relations because I don't have any data for them yet. I've got enough experience with this that I can tell from the equation if it's a function or not, but you guys don't, so we're going to go through it piece by piece. All right, so domain. So this is my domain. I don't know if you can squeeze the domain in there, and this is going to be my range. So this is my independent. This is my dependent. And again, you don't have to do that. You just have to know those. So I'm going to take every opportunity I can to make sure I'm writing those down so that I remind myself. The more I write it down, the more I talk about it, the more likely I am to remember. Okay, so the x values. We're going to make up the independent ones. Make up. Or maybe we'll say we're going to pick those ones. So we get to pick them. And what I like to do is I like to take a few negatives, I like to take 0, and I like to take a few positives. So I'm pretty consistent in the values that I pick. You can pick different ones if you like. There is no problem with that. But these are the ones I like to pick. I like to pick -2, -1, 0, 1, and 2. And I picked those. I made, like, it's because I got experience with it. So I picked those up. I picked those out of my little brain. I said, okay, I want to see what some negatives do. I want to see what some positives do. And 0 is always interesting as well. Okay, so now we're going to take those values and we're going to substitute them into the equation. So I'm just going to pop to a scrap piece of paper, and you guys can just watch as I do this. So my equation is y equals negative 3x plus 25. And my table of values was negative 2, negative 1, 0, 1, 2. So that was my table of values. So what I'm going to do is I'm going to take this x and I'm putting it into the equation where I see x. So y equals negative 3. What's the operation between the negative 3 and the x? Rahat?
Multiplication?
Multiplication, absolutely. So negative 3 times negative 2 plus 25. Okay, order of operation tells me I got to do my multiplying first. So negative 3 times my negative 2 is a positive 6 plus 25. That's hopefully going to give me 31. So in my table of values, the coordinate pair is going to be 31. So when I plot that point, I'm going to go over negative 2, I'm going to go left negative 2, and I'm going to go positive, so I'm going to go up to 31 on my graph. Everybody good with that? So I'm going to show you all the calculations for them. Sometimes you're confident enough to do them in your calculator or in your head if the equation is simple enough. Sometimes it's not. If you want to follow along with these, then please do. So now I'm going to put in y equals negative, or x equals negative 1. So negative 3 times negative 1 plus 25. So y equals a positive 3 plus 25. Y equals 28. Okay, so in my table of values, this is 28. Yeah?
The light from the sort of glare.
What?
The
Glaring?
light from the window sort of glaring on the screen.
Is it?
Yeah, sort of.
Can you still see it?
Not very much. I can't see the positive and negative signs.
I can't see the positive or negative signs. Okay. Better?
Thank you.
Okay, you guys do 0. I have the utmost faith you can do 0. You can probably do it in your head if you think about it. Did you get it, Steve? Did you do it in your head? And this is why I like 0 so much. It's a really easy calculation to do. What's 0 times anything? And 0 plus anything is just it's the thing. So it's that. My screen's really fuzzy. Oh, that is not better. Not better. Okay, next one, y equals negative 3 times by a positive 1 plus 25. Really easy to mess up or move or lose your positive negatives, so just pay attention to those. And if you're unsure or you're not confident using your positive negative numbers, please feel free to use your calculator, like until you start feeling comfort with that. Okay, and the last one you guys are going to do, because I'm going to fill this in on my other notes. You guys are doing that because we still have to graph it. You're gonna do the last one on your own. No, oftentimes I'll do all this math on a scrap piece of paper so that I don't clutter up my table. So I'm gonna go back to my notes. Did you guys get 19 for the last one? Okay, good job. Way to math it out. All right, so here's the thing. So we're gonna graph this relationship. I'm gonna need a ruler. I got my handy dandy ruler here because I need to make my X and Y axis. Maybe I'll do it in blue. All right, if you guys don't have a ruler and need one, at the back of the classroom, there's a drawer that has rulers in it. It's in a green drawer back there with rulers. You can grab one of those. You can do it without if you want to, but some of us are messier writers than others, and I always encourage using a ruler. All right, so when I put this together, do you guys see that I have positive and negative X values, right? Do I have any negative Y values here? No, I don't, right? But they're really high numbers. So that's going to change what I do with my increments as well. So I'm going to leave myself a lot of positive Y. I'm going to draw my X first. I'm going to leave myself a lot of positive Y. And do you guys know that you can have a different scale on your X and Y axis? You know what I mean by that? Like I can go up by 1s or 5s here, and I can go up by 10s here if I want to. Does that make sense? Your X and Y, you can put different scales on them. And I'm going to do that for this one. Okay, what's my highest number that I have to get to? 31. What's my lowest number? 19. So I'm going to have a bunch of numbers that are really, really they're really high up there. They're not like 1s and 2s and stuff like that. So I kind of have to figure this out, what I'm going to do. What do you think I should go up by on my Y-axis? Could I go up by, oh, that one was not good. What if I went up by 5s like that? Every second one 5. Would that work? Before you write it down, would it work? Am I going to get that 31 on there? No, I'm not. Sometimes it's not important to get all your points on there, but you should get the majority of them. I think I like the 5s. I think I'm going to stick with the 5s. You guys know that this would be 30 right there, right? So it'd be 1 above. It's pretty close. On my x-axis, I don't need to go up by 5s because the numbers are really quite close together. So maybe I'm going to go up by 1s here. And I would really encourage you to use a pencil when you're doing this because sometimes you end up having to change your increments. Is everybody good with that? Okay, so that's just getting the graph prepped. I haven't actually graphed my data yet. So that's just getting my graph prepped. So now I'm going to plot my points. So you guys all remember that this is my x-axis and this is my y-axis. So x runs horizontally. And so this tells me where I am on the x-axis. So I'm going to -2 on the x-axis, but I'm going up to 31. Well, that's off my graph. So I'm not going to graph that one. So now I'm going to go to -1 and I'm going to go to 28. Well, there's 25. So this would be, would you guys agree that would be 27.5 right there? Because it's like 2.5, it's halfway. So I'd just be just above that line. And at 0, so that's 0 right there. At 0, I'm at 25. Oh, good, that's right on the line. So I'm just a little bit above there. And at 1, I'm at 22. almost to that line. And then at 2, I'm at 19, so I'm just under that line. So what do you notice about my points? They're kind of in a straight line. So we can go ahead and connect those, and we're going to talk a little bit about when we connect and when we don't connect. And they should connect in a straight line. So see, I'm using a ruler. So this one's a little wonky. Maybe I should have brought it down a little bit. Now the question is, do I put arrows on it or not? Could this data continue if I kept putting plot points in my table? Yeah, I could figure out what 3 is. That's just doing more math. So if we can do that, we're going to put arrows on saying, hey, this continues on, but I'm a mathematician, so I'm not going to graph all possible points. I'm going to graph some so you can see the shape of my graph, but I'm not going to go any further than that. The arrows indicate that you can go further. Okay, how does everybody feel about their graph? Does it look good? Okay, all right. Okay. All right, I'm going to flip the page. Everybody go with me flipping the page. More graphing. Ooh, this is exciting. Welcome to grade 11 pre-cal. Well, welcome to grade 11 pre-cal or grade 11 applied. We do it in both. Ooh, going back to this one. Sorry, I'm flipping back to that first page there for a second. Is that a function? Is that a function? Yes, it is a function. How come? No repeats in the domain. It doesn't double back on itself, right? Like it's a nice straight line. There's no double X's anywhere. All right. We're going to do some math. We're going to do some order of operations. So again, remember that this is the domain. And this is the range. And we pick those X values. So we pick the domain. So I'm going to pick my same ones, -2, -1, 0, 1, 2. I'm very consistent in what I do. You can choose other ones if you want to. Okay, this is exciting. Order of operations. I'm going to go off to my scrap paper for a second. So, use the back side of this. So my formula or my equation was y equals 2x squared plus 5. My table of values was -2, -1, 0, 1, 2. All right, so we're going to substitute in -2 where we see the x squared. Well, where we see x, and it just happens to have a squared on it. So y equals 2 times -2 squared plus 5. So order of operation tells me, do I multiply or do I do with my exponents first? Definitely my exponents first. So I'm going to deal with this -2 squared. So that happens first. Oh, I kind of went over that other two. The exponent happens first. So what's -2 times -2? Positive, hopefully 4. And 2 times 4 is 8. And 8 plus 5 is 13. So 13 goes in my table. All right. Far row by the window, you guys are going to do -1. Next row, you guys get the easy one. You get to do 0. Summer, your row is going to do 1. So you guys are all going to calculate 1. And you guys are going to calculate +2. Okay? All right, so everybody's going to contribute a single value to this table of values. So all you have to do is calculate one value. Yep. It does.
can you have the same range?
Because, what does that squared do?
Positive, negative, positive?
Right. So what we're graphing here is parabolas from grade 11.
Parabola?
It's called a parabola. When we graph it, you're going to see it makes a nice U shape. And that's called a parabola. And we do a lot of work with those in grade 11.
Miss Gallion,
Uh-huh.
so technically with graphs,
Mm-hmm.
can we, using these domain and range, can we draw pictures on graphs?
What do you mean, draw pictures?
Like technically using our X values and Y values?
Well, like a graph is a picture. It's a pictorial of the like the equation.
Yeah.
Okay. All right, negative ones. What did you guys get? Did you confer? What did you get? 7. Yes. Woo! 7's correct. Taylor, your row. You guys got the easy ones? 7. No, you did 0. You were supposed to do 0. But did you do negative 1? Because you just confirmed their answer of 7, which is awesome. Did anybody do 0? Karen, did you guys do it? Jess, you did it? What did you get? 5. Beautiful. Okay. You guys were supposed to do 1, positive 1. What did you guys? Perfect. 7 is correct. You guys were positive 2. What did you guys get? Steve? 13. You are correct. So that should be your table of values for this one. This one looks a little bit different. This one looks a little bit different. Okay, so I'm going to put in my X and Y axis. So I'm going to get my handy dandy ruler. Do I have any negative values in my Y? No, not really, but I do have some negative values in my X. So my graph's going to look really similar to what I had last time, where I set it up on the page. All right. Oh, I should have made it lower. Boo. All right. I should have made this lower, and I used non-erasable pen. Okay. I'm gonna go 2, 4, 6, 8, 10, 12, 14. That's a 14. That's really tiny. I'm gonna go use the same scale that I used on my last one, where I skip 1 for every number. And this would be a -2, a -4, -6, -8. That is a really bad 14. I'm going to fix that. Now, when you're labeling your increments, you do not have to label every one. Like, you could skip them if you wanted to, if that makes more sense to you, if your writing's a little bit bigger than mine is, or you wanted to skip it, but you got to keep the pattern going. So when we talk about scalar increments, these have to follow the exact same pattern, okay? It has nothing, you make your max and min, like how high you go and how low you go, based on your table of values, but these have to be, okay, this space is 2, then this space here has to be 2. So your increments have to be the same thing. Okay, let's graph this data. So at -2, I'm at a +13. So I'm right there. And at -1, I'm at a +7. At 0, I'm at 5. And at 1, I'm at 7. And at 2, I'm back to the 13. So, ladies and gentlemen, you have just graphed, and we're going to connect those dots with a smooth curve. Smooth curve. I'm going to put arrows on it because I really could keep going if I just kept doing calculations in my table. So I'm going to put arrows on it to say, hey, I'm going to go on forever. You've just graphed what we call a parabola, just in case you're wondering. So that's called a parabola. You're not going to be tested on that. It's just so you're familiar with the name of the shape. We do a lot of work in grade 11 applied and grade 11 pre-cal with parabolas and quadratics. That is a quadratic equation, and when you draw it, it ends up being a parabola. So there you go. There's grade 11 in a nutshell for you. How do you feel about that one? A little bit different? Is it a function?
No. Yes, 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 yes.
Do the y values repeat?
Yes.
Yes. Does that matter? No. It's only the x values, right? So yes, this is a function. Even though we had some y values repeat, that doesn't matter. It's only the x values. Okay. Ooh, these are my favorite. These are my favorite from grade 9. If you look on my back wall, the Mondrian art, a mid-century artist who liked to use red, blue, and yellow in their drawings, and just linear lines, horizontal, vertical lines. And that's the colors that I got from the door. So that's the Mondrian art there, but that's the golden ratio. So lots of math stuff tied into these colors. So this is the equation of a horizontal line. Weird. Yes, I know. This is going to result So that's going to result in a horizontal line graph. And you guys are like, well, Scallion, you just ruined all the fun for us. And I'm sorry, I just got excited. When it's y equals, it's a horizontal line. And when it's x equals, guess what it is? It's a vertical line. Now, is there an x in this equation? No, that's kind of weird. That's okay, though. I'm still going to use my x's that I normally use. But what do we know about the y values? Does x impact the y values? The answer is no. I'm shaking my head no if you can't see it. What is y? Y is 5. It doesn't matter what x is. Guess what y is? 5. It says y is 5. So y equals 5. Y is 5. So all of these, I don't even have to do any math. I don't have to get a piece of scrap paper out. Life is wonderful. So exciting. Okay. Oh, and one thing I didn't do though, but this is my domain still. And this is my range. Okay, looking at that table of values, is this a function?
Yes.
Yes, it is. Y values repeat, but we've decided that that doesn't matter. It's when our x values repeat. Okay, so I'm going to draw this on there. There's my x-axis. Are you guys okay? There's like giggling and going on. Who knew that horizontal lines were going to be so exciting? One, two, 3, 4, 5. I'll go at one more, 6. All right. So, and again, this would be -1, -2, -3, -4, -5. Just to let you know, like I said, you can skip them, but you do have to put a few on each axis so I know what your increment or your scale is. Okay, I'm going to plot my points. At -2, I'm at 5. At -1, I'm at 5. At 0, I'm at 5. At +1, I'm at 5. At 2, I'm at 5. What kind of line do you get here? The horizontal line, right? So arrows on this, because really I could keep going forever if I needed to. I just don't have that kind of time in my life. So I'm going to put arrows on it. And there's my graph. And you guys did this in grade 9. You did horizontal and vertical line equations in grade 9. Whether you remember or don't remember, the students who drew those are graduating this year. So my goal is to get those off my wall and find my students who are graduating and give them back to them. They're pretty pictures. Okay. Ooh, I ruined the fun for this one. Okay. What are x's?
1,
I can't pick them now, right? They're determined for us. So what are our x's? 1. They're 1s all the way down. Because my equation says x has to be 1. X is 1. Does it matter what y's are? No. So we can actually go ahead and pick the y's on this one. And I'm just going to pick, because I'm a creature of habit, those are the ones I want to pick.
but it could be anything.
Could be anything.
So 269.
You have to graph that. Yeah, it's fine to pick any numbers that you want, but why would you pick like 1,000,000 or 100? Because you'd need to put that on the graph.
Should I just do all 0?
No. Because then you'd only have a single point. And that's not, one single point is not enough to graph, right? You've got to have multiple points. So these are all unique points, right? These are all unique points. Before we graph this, is this a function?
No.
How come it's not a function, Rahat?
The x's, which are our domain, are dependent values. They have repeated.
Yes, our domain has repeated, so this is not a function. This is the first time we're seeing not a function in this. All right. Okay, I'm going to graph this. All right, so this is not very exciting. This is 1, this is 2, this is 3. Notice nothing really has changed on my x-axis for all of these graphs. My y's have changed though, and my y's I'm going to have -1, -2, 0, that's 1, that's 2, that's 3. This time I've spaced it out a little bit. All right, we ready to plot the points? So when x is 1, it can be -2. When x is also 1, it can be -1. When x is 1, it can be 0. When x is 1, it could be +1. And when x is 1, it could be a +2. I'm going to put arrows on those because those could continue on for a long time if I wanted to. And so we said this one was not a function. It was not a function. And what you notice is that if it's not a function, you end up having points stacked on top of each other in the vertical. Okay? Everybody good with that? All right. Okay, so what I want to do is I want to go grab a graphing calculator right now.